Hello and welcome to another GCSE Maths walkthrough, and in this one we'll be looking at the higher tier paper, and it's going to be paper 2, which is a calculator paper, and then next weekend I'm going to be doing paper 3. So I've gone through all of the instructions in previous videos, so I'm not going to bother with any of those. So just going to crack straight on with the first question. And just to mention that the paper, this particular predicted paper, the link for this is in the video description. So please click on the link and try to follow along at home. And as always, I hope this is really beneficial for your upcoming exams. So question 1. Describe fully the single transformation that maps triangle A onto triangle B. So with this, it's definitely been enlarged. The first thing I can see has been enlarged because we're going from this shape to this shape here. So I'm going to write that down first. So enlarged. What is the scale factor of enlargement? So we can just pick out one of the side lengths. So we can see that it has a height of 2 squares. And after it's been transformed, it now has a height of 4 squares. So the scale factor is 2. So it's been enlarged by a scale factor 2. And now we need to say where the centre of enlargement is. And for this, you should get your ruler out and draw some lines that go from corresponding points. So if we pick the bottom left-hand corner of the large triangle and draw a line through the bottom left-hand corner of the small triangle. Okay, I'm going to make that a bit thinner. There we go. And now we do that for all of our points, all of our vertices. So I'm going to draw another line, straight line, from the bottom right-hand corner of our triangle through the bottom right-hand corner of our original triangle. Okay, and you might be able to see where the centre of enlargement is already, but let's just complete this. So again, another line from the top right-hand corner of our triangle through the top right-hand corner of this triangle, and obviously it's not perfect, but hopefully you can see where the center of enlargement is. Let's just mark that on our coordinate grid. So that is our center of enlargement, so we need to write that down. So it's been enlarged by a scale factor of 2. You could just say about the point, and then we need to write the coordinates. So about the point where we're going along 6 and down 7. So 6, -7. Question number 2. A number is rounded to 2 decimal places and the result is 0.18. Write down the error interval for x. So we've got the template for our error interval. So we just need to work out what the lower bound is. So this number will be the lower bound and this number will be the upper bound. So our number is 0.18 and it has been rounded to 2 decimal places. So if we first think about our lower bound, what is our lower bound going to be? Well, it's going to be smaller than this number because it needs to round up to 0.18. So what's the largest possible number it could be that when rounded to 2 decimal places gets rounded up to 0.18? Well, it's going to be 0.175. Because if we think about it, if we round this number to 2 decimal places, so that's our first decimal place, that's our second decimal place. So we look at the 5, and because that's 5 or greater, we would round this up to an 8. So that would round to 0.18. Anything smaller than a 5, so if this was 0.174, then it would get rounded down. So 5 is the first number that we come to that would make this number round up to 0.18. So our lower bound is 0.175, and our upper bound, well, it's just the same distance away from our number but above our number, so it would be 0.185. And you need to be really careful here because we're not saying that our number is 0.185, because if it was, then this would get rounded up to 0.19. And the really important part is this inequality here. This specifically states that our number is less than 0.185. This inequality says our number is greater than 0.175, but it can be equal to. That extra dash shows that it can be equal to. Okay, so you just need to be really careful with your upper and lower bounds. Question 3. Simplify a to the power 9 multiplied by a to the power 4. Well, these are part of your laws of indices. And you just need to remember that when you multiply things with the same base, we add our indices. So this is a to the power 9 plus 4. Okay, we just add our indices, which gives us a to the power 13. So our answer is a to the power 13. Okay, part B, simplify in brackets 4b squared c, and then all of that is being cubed. So this is 4b squared c times 4b squared c times 4b squared c. So everything inside the brackets is being cubed. So if we do 4 cubed, so it's going to be 4 cubed times b squared cubed. So b squared cubed times c cubed. So everything is being cubed. So what is 4 cubed? Well, 4 cubed is 4 times 4 times 4, which is 64. And remember, you can use a calculator. And b squared cubed, well, what happens when we raise something to a power and then a further power? Well, we multiply our indices. So this is going to be b to the power 6. And finally, we've just got c cubed tagging along at the back there. Okay, now simplify d to the power 9 divided by d to the power 4. And again, another one of our laws of indices. When we divide things with the same base, we subtract our indices. So this is going to be d to the power of 9 minus 4. Okay, and 9 minus 4 is 5. So our answer is d to the power 5. d to the power 5. Question number 4. Given that the ratio a to c is 1 to 6 and the ratio b to c is 2 to 5, find the ratio a to b to c. Give your answer in its simplest form. So we've been given 2 ratios. Let's write this down. So we've got the letters a, b, and c. The first ratio we're given is a to c is 1 to 6. So 1 to 6. The ratio a to c is 1 to 6. And we're also told that the ratio b to c is 2 to 5. So 2 to 5. Now, we need to find the ratio a to b to c. So we look at which letter we've got a common digit of. So c, and what we're going to do is find the lowest common multiple of 6 and 30. Sorry, I've just given you the answer there. Sorry, 6 and 5. The lowest common multiple of 6 and 5 is 30. So we can put 30 as one of our parts of our ratio for c. Now, what we do now is have a look at one of our ratios that we've been given. So we know the ratio b to c is 2 to 5. What is that the same as if our number for c is 30? So 2 to 5 is something to 30. Well, to work out our missing number, what did we do to go from 5 to 30? Well, we multiplied by 6. So we need to do exactly the same to b. We need to times that by 6. And 2 times 6 is 12. So hopefully you can see what I've done is I've just found an equivalent ratio. 2 to 5 is exactly the same as 12 to 30. And now we do exactly the same for the ratio a to c. So 1 to 6 is something to 30. And again, think about what did you do to go, or what did I do to go from 6 to 30? Well, I multiplied by 5. So I need to do exactly the same to a. I need to times by 5. And 1 times 5 is 5. So we have got our ratio a to b to c is 5 to 12 to 30, and this is already in its simplest form. So we can write that down as our answer. 5 to 12 to 30. So the key thing about this was this number here. Okay, first of all, finding the 30, and then everything else follows. And how I got the 30 is I just found the lowest common multiple of these two numbers. Question 5. Nick bought a new car. Each year the car depreciates in value by 12%. Work out the number of years it takes for the car to half in value. So, first of all, what does the word depreciate mean? Well, that just means go down. Okay, so it goes down in value by 12% every year. So whatever we buy it, whatever price we buy it for, the car for, every year it goes down by 12%. We need to work out how many years it takes for the car to become half of the value it started with. So let's first think about how much it is worth after 1 year. So year 1, well, if it's going down by 12% from the original price, it's going to be worth 88%. Because remember, we always start at 100%. Okay, 100% is the original price, it is brand new, and it's going down by 12%. So we're now worth 88%. The car is now worth 88%. And as a decimal, that is going to be 0.88. So we want to work out how many years it takes for this value to get to 0.5. Okay, that's the same as halving in value, 0.5. So what is it worth after year 2? Well, it's going down by another 12%. So we're going to take 88% of the price from year 1. We're not taking 88% of the original value, we're taking 88% of this value. So it's going to be 0.88 times 0.88. Or another way we could think about it is 0.88 squared. Okay, so let's get our calculator out. So 0.88 squared, that gives us 0.7744. So we need to keep going. Year 3, well, it's going down by another 12%. So we're going to take 88% of this value. So 0.88 squared times 0.88, which is just 0.88 cubed. So notice every year that goes on, we're multiplying by 0.88. So times 0.88 again, we get to 0.681472. We need to do it again. We need to keep going because we need to get to 50% or 0.5. We're not quite there yet. So year 4, 0.88 to the power 4. That gives us 0.59969,536. We're getting close. So year 5, is it going to reach it after year 5? So it's going to be 0.88 to the power 5. And that gives us 0.52. So we haven't quite reached it yet. 77319,168. So I think it's going to be year 6. But let's just verify that. So year 6, 0.88 to the power 6. So times 0.88 again. And yes, we get 0.4644040868. So it takes 6 years. It takes 6 years. We're interested in whole years. It doesn't say number of years and number of months or number of days. So year 5, it hasn't quite reached 50%. It has to take until year 6 for the car to halve in value. So our answer is going to be 6 years. Question 6. In London, potatoes cost £0.45 per pound, as in the weight pound. In Dublin, potatoes cost €1.48 per kilogram. And we've got some conversions here between kilograms and pounds and euros. In which city are potatoes better value for money? London or Dublin? You must show your working. So we're going to have to do some conversions here. So let's convert everything into pounds, I think. Doesn't matter which one you convert to, but you need to be consistent. So London is 45 pence per pound, or 0.45 pounds per pound. Now let's look at Dublin, but let's convert the kilograms into pounds. So Dublin, how much does it cost in Dublin? Well, let's just first of all copy it out. So it's €1.48 per kilogram, but we want to convert the kilograms into pounds. So we want to work out how many euros it costs per pound to begin with. And then once we've got that, we can then convert the euros into English pounds sterling. So I'm trying to differentiate between pounds the weight and pounds the unit of money. So let's look at our conversion. We're going to look at top conversion first. So there are 2.2 pounds per kilogram. So a kilogram is 2.2 times bigger than a pound. So we're going to have to divide by 2.2 because remember pounds are smaller. So however much it costs is going to be 2.2 times cheaper per pound. So we are going to divide by 2.2. So let's just do that. €1.48, 1.48 divided by 2.2. That gives us 0.67. So 0.67 euros per pound. And now we want to work out how much that costs in pounds per pound. Pounds per pound. So now we're going to look at our other conversion between pounds and euros. So there are 1.15 euros to every pound. So we are going to go from pounds to euros. We're going to divide by 1.15. So we're going to divide this by 1.15 now. Let's write that down. So we're going to divide by 1.15. And I'm just going to do answer divided by 1.15 because it's still stored in my calculator. And I get 0.58. I round that to 2 decimal places. So that is, and let's just make sure that is in Dublin. So London is 45 pence per pound. Dublin is 58 pence per pound. So which one is cheaper? It is London. So we need to say, which city are potatoes better value for money? London. You must show all your working. Well, here is all of our working here. So the two important points or numbers are this number here and this number here. Question 7. The diagram shows a patio in the shape of a rectangle. Jack wants to cover the patio with paving slabs. Each paving slab is a square of side 40 centimetres and the paving slabs cost £7.59 each. Jack has £300 to spend on paving slab. Does Jack have enough money to cover the patio with paving slabs? Right, so let's first of all look at the paving slab. So each paving slab is a square of side length 40 centimetres. So imagine, this is obviously not drawn to scale because I think the paving slabs will be a bit smaller than this. So 40 centimetres. Now we've been given the measurement of our patio in metres, but we've got the measurement of our paving slabs in centimetres. So we can just convert this into metres. So 40 centimetres is 0.4 metres. So each side length of our patio is 0.4 metres because it's a square. So what the first thing we can do is we can work out the area of the patio. So 3.6 times 1.6. So let's write this down. So area of patio equals 3.6 metres multiplied by 1.6 metres. 3.6 times 1.6. That gives us 5.76. 5.76 metres squared. Now let's work out the area of a paving slab. So area of a paving slab. So that's going to be 0.4 metres multiplied by 0.4 metres, and I can do that in my head. That's going to be 0.16 metres squared. So we've got the area of the patio, the area of the paving slab. So to work out how many paving slabs we need, we can just divide the area of the patio by the area of a paving slab. So number of slabs needed, well, it's going to be 5.76 metres squared divided by 0.16 metres squared. So divide by 0.6 and we get exactly 36, which is nice. So we need 36 slabs. That's the total number of slabs we need. And we know how much each of the slabs cost. They're £7.59 each. So to work out the cost, it's going to be 36 multiplied by £7.59. So put that into the calculator and we get £273.24. Now we're told that Jack has £300 to spend. Does he have enough money? Yes. So we can put yes. Jack has enough. Okay, and then we could just put in brackets. So £273.24 is less than £300. We don't need to work out how much change he gets. He gets quite a bit of change, so he's done well. He's done well with purchasing all of his paving slabs. So he definitely has enough money. Question 8. Use your calculator to work out this calculation here. Write down all of the figures on your calculator display. So this question is just testing your ability to use a calculator. So it's the square root of this fraction. So the first thing you need to type into your calculator is the square root button. Okay, that's the first thing you need to type in. Now type in the fraction button, okay, because we've got a fraction here, and make sure your cursor is in the numerator. You're going to type in tan. Now when you type in the tan button, it should automatically open the brackets for you. So you're going to type in 80 degrees. Make sure you close your brackets. If you don't close your brackets, what you're going to do is on your calculator, basically, when you press +1, if you put this in, and let's say you don't even close the brackets, this will take the tan of 81 degrees. We're not working out the tan of 81 degrees. We're working out the tan of 80 degrees +1. So whatever the answer to the tan of 80 degrees is, then we're adding on 1. So we need to make sure we close our brackets. So tan of 80 degrees and then +1. And now move into your denominator. We're doing the same thing. Tan of 80 degrees, close brackets, and then this time take away 1. So now I'm just going to type all of that into my calculator. So tan 80, close brackets, +1, go down, tan 80, close brackets, -1. And we're going to write down all of the figures on the calculator to display. So it's 1.195051.466. Okay, write your answer to part A correct to 3 significant figures. So this is our first significant figure, this is our second significant figure, this is our third significant figure. So we're going to have a look at this digit here to tell us whether to round up or down. So it's either going to be 1.19 or we're going to round up to 1.20. And the 5 tells us to round up. So it's going to be 1.20. Make sure you include that last 0. It's not 1.2 because that would be only rounding to 2 significant figures. So that 0, that shows the examiner that you have rounded to 3 significant figures. Question 9. Lucy is 3 times older than Alex, and Lucy is 7 years older than Megan. The sum of their ages, so all 3, Lucy, Alex and Megan's ages, is 126. Find the ratio of Alex's age to Lucy's age to Megan's age. So there's quite a lot involved here, and it's worth 4 marks. Well, the first thing I'm going to do is just come up with some abbreviations. So let's say that A is Alex's age. Let's say that L is Lucy's age. And let's say that M is Megan's age, just so we don't have to keep writing their names down. And now we've put all of the names as different letters, we can just go through each sentence and write down an equation for each one. So Lucy is 3 times as old as Alex. So that will be L equals 3A. Lucy is 3 times older than Alex. We're also told that Lucy is 7 years older than Megan. So that is going to be M plus 7. Be really careful. It's not 7M. That would be 7 times older than Megan. It's whatever Megan's age is plus 7 years. And finally, we're told that the sum of their ages is 126. So that would be A plus L plus M equals 126. So I'm going to try and stop using their names now and just use the letters. So we know that A plus L plus M equals 126. What I'm going to try and do is I'm going to try and write an equation for Lucy, or an equation for L in terms of A, and also write an equation for M in terms of A. so that we have everything in terms of A. We could then work out how old Alex is. So we know, first of all, we know that L equals 3A. So straight away, I can just replace this L with 3A. So that would be A plus 3A plus M equals 126. So now we've got two of the terms with A in. We just need to try and get M in terms of A. So how can we get M in terms of A? Well, we can put M in terms of L. We've got L and M that relate together, Lucy and Megan. So using this equation down here, we can say that Megan, or M, equals L minus 7. I've just taken away 7 from both sides. And now I can use this top equation. I know that L equals 3A. I can just replace this L with 3A. So M is equal to 3A. I'll just replace the L with the 3A minus 7. So now I know that Megan is 3 times Alex's age minus 7. And now I can just pop this into this part here. So wherever M is, I can replace it with 3A minus 7. So we've got A plus 3A plus M, which is 3A minus 7. And that equals 126. Now we can just solve this equation. So A plus 3A is 4A plus 3A, that is 7A. So we've got 7A minus 7 equals 126. Now if we add 7 to both sides, we get 7A is equal to 133. And then divide both sides by 7, we get A is equal to 19. So Alex is 19. Now we can work out how old Lucy is. Lucy was 3 times Alex's age, so 3 times 19 is 57. And finally, Megan was Lucy's age minus 7, so we just need to take away 7 from 57, which is 50. Apologies, that's my phone going off. Not important though. So let's just double check. Do these add up to 126? That's 107. 127 minus 1, 126. Yes, 126. So these are the correct ages. Now we just need to write our answer. So find the ratio of Alex's age to Lucy's age to Megan's age. So it is in this order here. So our ratio is 19 to 57 to 50. And we cannot simplify this. So this is our final answer. Question 10. Find the equation of the line parallel to 2x plus 5y equals 10, which passes through the point 0, 3. So the first thing you should remember about parallel lines is they have the same gradient. So let's first of all work out what the gradient is of this line. So we've got 2x plus 5y equals 10. Now, the easiest way I find to find the gradient is if we put it in y equals mx plus c form. Okay, because when we get it in this form, we know that m, whatever number is in front of the x, is the gradient. Okay, so let's make y the subject. So the first thing to do, let's get rid of this 2x. So if we take away 2x from both sides, we're now left with 5y equals negative 2x plus 10. And now if we divide both sides by 5, so if we divide both sides by 5, are we left with? Well, we've got y equals, so remember we're dividing everything by 5, so let me just make that clear. I'm going to get rid of that. We're dividing everything by 5. So we're dividing the negative 2 by 5, and we're also dividing the 10 by 5. Okay, that just makes it a bit clearer for you. So negative 2x divided by 5, well, that's just negative 2 over 5x. And then plus 10 over 5, well, that is just 2. So this is the equation of our line. So what is the gradient? Well, the gradient is negative 2/5. So gradient of our line is negative 2/5. So let's just box that. That's the gradient of our line. So the gradient of the equation of a line parallel to this line has to have the same gradient, and it has to pass through this point. So if we use the fact we've got the coordinates for our point. So when x equals 0, y equals -3. So we can substitute these two values into our general equation, and we can also substitute the gradient is, and then that way we can work out what the y-intercept is. So y, we know y is -3. So when y equals -3, that equals the gradient, which is -2/5, -2/5, multiplied by x, which is just 0, plus c. So well, it doesn't matter what we're multiplying by, this is just going to be 0. So it's going to be -3 equals 0 plus c. So therefore c must equal -3. So we've got our y-intercept now, and we've got our gradient. We can write down the equation. So our equation of our line is going to be y equals -2/5 x, -2/5 x, and then -3. And in fact, I didn't really need to do all of this working out, because I can see here that the y-intercept is -3, because when x equals 0, y equals -3. So our y-intercept is -3. So I didn't really need to do all of this. I just didn't really look at what the coordinates were. Question 11. Carlos wants to find an estimate for the number of ants in a colony. He catches 60 ants from the colony and marks each one with a die. He then returns the ants to the colony. A week later, Carlos catches another 60 ants, and 8 of these ants are marked with a die. Work out an estimate for the number of ants in the colony. So Carlos catches 60 ants from the colony and marks each one with a die. So we know that there are at least 60 ants. At least 60 ants, otherwise he wouldn't have caught 60 ants. But then it says he returns the ants to the colony. So we're not taking those 60 ants out. That would obviously reduce the number of ants in the colony. We're putting them back in, so that the number hasn't changed. And then it says a week later, Carlos catches another 60 ants, and 8 of these are marked with a die. So 8 out of 60 are marked. So there's a lot more than 60, because if there were exactly 60, then all of them would be marked. But only 8 out of 60 are marked. Now, because he's just taking a random sample of ants and 8 out of 60 are marked, well, this will be the fraction of the total number of ants that are marked. Okay, so we can say that 8 out of 60 of the total are marked. So we know that there were 60 ants that were marked in total, because we were told right at the beginning that he marked 60 ants. So 60 out of the total must equal 8 out of 60. So to go from 8 to 60, what have we done? Well, let's just do 60 divided by 8. That gives us 7.5 times 7.5. So if we just multiply the numerator by 7.5, we get 450. So an estimate for the total number of ants in the colony is 450. Now, we don't know it's exactly going to be 450, because we are taking a random sample. But hopefully that makes sense, because we're marking 60 ants. Let's just go through this once more. We're marking 60 ants, and the probability of picking an ant out that was marked was 8 out of 60. Okay, so that's why the 60 that were marked out of the total must be equal to 8 out of 60. So that's where we get the 450 from. Now, if we look at part B, it says Carlos assumes that none of the marks had rubbed off. If Carlos's assumption is wrong, explain what effect this would have on your answer to part A. So when Carlos picked out his sample of 60 ants, 8 of them had marks on. But now what we're saying is that the marks can be rubbed off. So it's likely that there were less than 8. They could still be 8 if none of them had rubbed off. But this number here, this can't go up. This can't go up because we can't add marks to the ants, but it can go down. So if even one of the ants had its mark rubbed off, then this would now be 7. Okay, so how does that affect this number here? Well, this number is going to go up. If this number goes down, okay, so if the fraction of ants with marks on goes down, then there's obviously got to be more ants in total. So we could say So for our answer, what effect would this have on our answer to part A? Well, the total number of ants would go up if some of the ants had been rubbed off, or some of the ants marks had been rubbed off. Question 13. It takes 30 builders 12 days to complete a job. Work out how many days it would take 40 builders to complete the same job. So let's write this down. So 30 builders equals 12 days. We need to work out how long it takes 40 builders. Now let's just think about 10 builders. Let's break it down. So how long would it take 12 builders to complete the same job? Well, there's 3 times less builders, so it's going to take 3 times longer. So it's going to be 3 times 12, which is 36 days. And now we can work out how long it's going to take for 40 builders. So now we've got 4 times as much builders, so it's going to take 4 times less time, or I should say 4 times. It should be 4 times as quick. So 36 divided by 4 is 9. So it's going to be 9 days. 9 days. And now part B says write down any assumptions you made in part A. Well, we're assuming all of the builders work at the same pace. Okay, because we've got different builders. You know, the 10 extra builders might be super quick, or they might be super slow. So we have to assume that the extra builders work at the same pace. Okay, it's only one, mark that one, so we just need to give one assumption. Question 14. Given that f of x equals 2x minus 4 and g of x equals 3x plus 5, find g of f of 3. So this is the topic of composite functions, which is just functions within a function. So we have to work on the inside first and work our way outside. So f of 3, let's first focus on that part. So f of 3, that part there. So what is f of 3? Well, that just means if I put 3 into my function, what is my output? So if 3 is my input, what is my output? So here's the f function. So I just need to substitute 3 into this this function here. So it's going to be 2 times 3 minus 4. So 2 times 3 is 6. 6 minus 4 is 2. So we can say that f of 3 equals 2. I need that last bracket on there. And now I need to put 2 into my g function. So now I'm going to look at the g function. Let's just, there we go. And now I'm going to do g of 2. Let's write that down. Now I'm going to do g of 2. So I'm just going to substitute 2 into this function here. So it's going to be 3 times 2 plus 5. Well, 3 times 2 is 6. 6 plus 5 is 11. So our answer is 11. Now for part B, it says work out an expression for f inverse of x. So what we're doing here is we're doing the inverse operations. We're saying that you give me an output and I'll tell you what the input is. For both of these functions, we're saying you give me an input and I'll give you an output. Here we're saying you give me an output and I'll tell you what the input was. So we're working backwards. So if we start with our original function, and instead of putting f of x, I'm just going to change that to y. So y equals 2x minus 4. This is what we're used to saying. So y is the output and x is the input. So now we're trying to rearrange this formula so that x is the subject. Okay, so the first thing I'm going to do is I'm going to add 4 to both sides. So if I add 4 to both sides, what am I left with? Well, I've got y plus 4 equals 2x. And now to get x on its own, if I divide both sides by 2, divide both sides by 2, and I am left with x equals y plus 4 over 2. Okay. Now at the beginning we changed the x to a y, so we have to change that back. So we have to change this back to x plus 4 over 2. So it's going to be x plus 4 over 2. So that is going to be our inverse function. So our inverse function, f inverse of x, is going to be x plus 4 divided by 2. Okay, now we have a look at question. Let's look at part C. Solve f of x equals g of x. Well, we're told what f of x is. F of x is 2x minus 4. And we're told what g of x is. G of x is 3x plus 5. So we just need to solve this equation. So I'm going to get all of the x's on the right hand side. So I'm going to take away 2x from both sides. So that's going to leave me with negative 4 equals x plus 5. And now if I take away 5 from both sides, that leaves me with negative 9 equals x. So x equals negative 9. Okay, question 15. The diagram shows a solid shape. The shape is a hemisphere on top of a cylinder. The solid shape is placed on a table. The solid exerts a force of 4 newtons on the table, and the pressure on the table is 100 newtons per meter squared. The height of the cylinder is 45 centimeters, which we can see here. Work out the total volume of the solid shape. Now there is an awful lot here, which is why it is worth 6 marks. So it's going to take a while to do this question. We do have 2 of the formulae here. And the first thing I'm going to focus on is this formula. And the reason why I'm looking at this one is because we're told the force and we're told the pressure. So we can work out the area using this formula. So the pressure is equal to the force times the area. So if we rearrange this formula to put it in terms of the area, that means that the area is equal to the force divided by the pressure. Okay, so we're working out the area of this circle. Okay, because it's the area. The solid exerts a force of 4 newtons on the table, which is encompassed by this area, and the pressure on the table is 100 newtons per meter squared. So we're looking at this area here. So the force, well, the force is 4 newtons. So it's going to be 4 newtons divided by the pressure, which is 100 newtons per meter squared. 4 divided by 100 is 0.04. So it's going to be 0.04, and the units are going to be meters squared. Now, before I go any further, I'm just noticing that the height is given in centimeters, but our area of our circle is in meters squared. So let's convert this into centimeters squared. So let's think about, how do we go from meters squared to centimeters squared? Well, we need to multiply by 100 squared. And you need to be really careful, because if we were just going from meters to centimeters, we would only need to multiply by 100. But because we're going from meters squared to centimeters squared, we need to multiply by 100 squared. So 0.04 times 100 squared, which is the same as 10,000. That gives us 400. So the area of our circle is 400 centimeters squared. So now we have the area in centimeters squared, and we've got the height in centimeters. Now we can work out the volume of our cylinder. So volume of cylinder, or it's going to be our area, 400 centimeters squared, multiplied by our height, which is 45 centimeters squared. And that gives us 18,000. 18,000. And the units are centimeters cubed. So that is the volume of our cylinder. But we don't know the volume of the hemisphere. That's what we're going to work out next. But in order to work out the volume of a hemisphere, we will need the radius. So let's work out the radius of the circle. So we know that this circle is exactly the same as this circle. Okay. So because we know the area of our circle, we can use that to work out the radius. So let's think about the formula for area of a circle. The area of a circle is equal to pi times the radius squared. So if we want to work out the radius, we have to rearrange this formula to make r the subject. So the first thing I'm going to do is I'm going to divide both sides by pi. So it's going to be a over pi is equal to r squared. And now if we square root both sides, we get our radius is equal to the square root of a over pi. So let's work out what this is. So it's going to be the square root of our area, which is 400 centimeters squared. So it's going to be 400 over pi. Can we simplify this? Well, the square root of 400 is 20. So it's just going to be 20 over square root of pi. And we don't have to simplify this. Actually, I'll probably leave that out. Let's just leave this as our final answer for the radius. Okay. So now we know the radius, we can work out the volume of a sphere. So let's just imagine this was a sphere. So let's work out the sphere first, and then at the end we can just half our answer. So the volume of the sphere, so let's do it down here. So volume of sphere, well, it's going to be 4/3 times pi. Times pi times our radius cubed times, so this is our radius, so it's square root of 400 over pi, and we're going to cube that. So that is going to be the volume of our sphere. So let's put that into a calculator. 4/3 times pi times, and then we need to make sure we type this in correctly. So let's put our brackets in first, and then our square root symbol. And then the fraction button, 400 over pi. And then let's get outside of the brackets. And now let's cube that thing inside the brackets. Press equals, and we get, I'm going to round this to the nearest whole number, 6,018. And our units are going to be centimeters cubed. So that is the volume of the sphere. So the hemisphere, so vol of hemisphere, well, it's just going to be half that. It's going to be half this number. So if we just divide that by 2, we get 3009. And it's going to be 3009 centimeters cubed. So the total volume, we're almost at the end. So total volume, well, it's going to be the volume of our cylinder, which is 18,000, plus the volume of our hemisphere, which is 3009. And I think we probably deserve a drum roll for this, because we've definitely earned that. So we're going to add those two volumes together, and we get a total of 21,000. I didn't really need a calculator for this, but hey ho, 21,009 and our units are in centimeters cubed. And luckily for us, we have to put our answer in centimeters cubed. So that is our answer, 21,009. Question 16. The diagram shows a rectangle. All measurements are in centimeters. The area of the rectangle is less than 45 centimeters squared. We need to show this inequality to be true. Right, so we're given an expression for the width and the length. So we can write an expression for the area of our rectangle just by multiplying these two expressions together. So the area is going to be 2x plus 7 multiplied by x plus 3. And there's a few ways you could do this. You could do the grid method, but I'm going to FOIL it out. So I'm going to multiply everything in these brackets by everything in these brackets by doing this. So 2x times x gives us 2x squared. 2x times 3 gives us positive 6x. 7 times x is positive 7x. And then 7 times 3 is plus 21. We can simplify this. So 2x squared, 6x plus 7x is 13x, and then plus 21. Now, if we look here, it says the area of the rectangle is less than 45 centimeters squared. So we can say that that is less than 45. And now if we look at our inequality here, the only thing that's different is on the right hand side we've got 0, here we've got 45. So if we take away 45 from both sides, so if we take away 45 from both sides, what are we left with? Well, we're left with 2x squared plus 13x, and then 21 minus 45 is minus 24, and that is less than 0, and we're done. We have shown that 2x squared plus 13x minus 24 is less than 0. Okay, looking at part B, find the range of possible values for x. So what could x be in order to satisfy this inequality? So first of all, let's solve this inequality. And to solve inequalities, I always change the inequality to an equal sign first, and then deal with whether it's greater than or less than afterwards. So I'm just going to copy down the inequality, but I'm going to change the less than sign to an equal sign. So 2x squared plus 13x minus 24 equals 0. And now I'm going to solve this. Again, there's a few ways you can solve quadratics. I'm going to use the formula, the quadratic formula. So I'm just going to write the formula. Actually, we're given the formula in the formulae sheet. So if you can't quite remember it, to solve any quadratic equation, we can solve it using this formula. So x equals minus b plus or minus square root of b squared minus 4ac, all of that over 2a. So we just need to identify what are our values for a, b and c. Well, a is the coefficient on the x squared term, which is 2. b is the coefficient on the x term, which is 13. And c is the constant, which is negative 24. So I'm just going to substitute these values into our expression, or into our formula. So x is going to equal negative b, so that's negative 13. Oh, I don't know what happened there. Negative 13 plus or minus the square root. Oh, excuse me. Sorry about that. Where was I? So plus or minus b squared. So 13 squared is 169 minus 4 times a, which is 2, times c, which is negative 24. Let's just extend our root symbol, and then all of that over 2 times 2, which is just 4. I can write 4 in. Okay, so let's type all of this into a calculator, and we will get 2 solutions. So the first solution I'm going to do, so it's going to be negative 13. I'm going to do plus first. So plus the square root of 169 minus 4 times 2 times negative 24. All of that divided by 4. So my first solution is 1.5. And my second solution, I'm just going to change the plus to a minus. And that gives me minus 8. So if I were to solve this equation, I would get these 2 solutions. But remember, we're not solving the equation, it's an inequality. So the easiest way I think of doing this is if we were to draw a coordinate grid, okay, and if we plot our solutions or our roots, so x equals 1.5, let's say that is about there, and x equals negative 8, that will be somewhere like that. So our quadratic, we sketch it, it's going to look, well, that's a very bad drawing, but it doesn't need to be kind of very accurate, but just you can see what's going on. So this is just a sketch of our quadratic. Now we're looking at what values can we put into the expression to give us a y value of less than 0. Well, anything less than 0 is going to be anything underneath our x-axis. So all of these values here will be legitimate. Okay, so it's anything, if you look at what are the x values, well, it's anything between negative 8, so that is negative 8, and 1.5. So it's anything between negative 8 and 1.5. So let's write that down. So negative 8 is going to be less than x, which is less than 1.5. Now we need to be really careful because this is almost our answer, but it's not quite right, because x, if you think about what x is, if we put in -8, let's say we substitute -8 into this measurement here. Well, the length of this is going to be -8 plus 3, which is -5. Now that clearly doesn't make any sense because you can't have a negative length. So we just need to have another look at our inequality and think about what values it could be. So obviously anything positive up to 1.5. So 1.5 is definitely going to be the maximum or the upper bound. So it's going to be less than 1.5. But what's the minimum it can be? Well, 0 is 0. Anything greater than 0 is possible. So how can we get one of these to 0? Well, if x equals -3, that will give us 0 here. But if x equals -3 here, that would be -6 plus 1 is plus 7 is 1. So actually -3 will be the minimum value, not the minimum value, the lower bound. So it can't equal -3. Can't equal -3 because then we would have a length of 0. But anything greater than -3 would work as well. Okay, so this will be our final inequality, or our final sort of range of values, I should say. Question 17. Sketch the graph of y equals 2 sine of x for x values between 0 and 360 degrees. So let's first of all, let's think about what the graph of the equation y equals sine of x would look like. Well, sine of x starts at 0, and then sine of 90 degrees will be 1. Let's just say 1 is here. We're not given any axes. Let's just write on 1 and -1 for our y-axis. Sine of 180 degrees is 0. Sine of 270 degrees is -1. And sine of 360 degrees is 0. So if I were to do, I'm just going to do this dashed. So this is what sine of x would look like. Obviously this is not a very good representation. It's a bit all over the place, but hopefully you get the idea. So that is sine of x. Now 2 times sine of x, well, we're going to take sine of x and we're just going to scale it up by 2. So we're going to stretch it up in the vertical direction by 2. So instead of this point now being 1, it's now going to be 2. So obviously I didn't really do this very well with my axes, but let's say I should really go down a bit further to -2. So our graph is going to be, I'll cross over these points. So it should be freehand. So it's going to look something like this. Okay. And for this particular question, it doesn't really matter too much how accurate the curves are. The most important points, okay, are these. Make sure when you labelled your axis, you have to label your axis with -2, because it goes from 0 up to -2, down to 0, down to -2, and then up to 0. I don't know if I said -2 here or not. I meant it goes up to 2, down to 0, down to -2, and back up to 0 like that. Question 18. The graph of y equals f of x is shown below. The coordinates of the maximum point of this curve are -2, 1, which we can see here. Write down the coordinates of the turning point of the curve with the equation y equals f of x plus 3. Right, so this is y equals f of x. So this is y equals f of x. Now think about what the graph of the equation y equals f of x plus 3 would look like. Well, everything's just going to be shifted up by 3. So if we're just adding on 3, whatever we get, our values for y we're just adding on 3. So we're just going to shift everything up by 3. So it's going to look, again, I'm just going to do a dotted line. Okay, and again, this is a terrible drawing, but all I've done is I've shifted this graph up by 3 units. So the turning point, which was here, is now going to be up here. So if it was -2, 1, or the -2, the x coordinate is still going to be -2. but the y coordinate is going to be shifted up by 3 units. So it's going to be -2, 4. So it's going to be -2, 4. Now we have to work out the turning point of this equation. So let's do it in 2 steps. So the first part, I'm just going to focus on what's in the brackets. So in blue, I'm going to plot the graph of the equation y equals f of x plus 2. So I'm not worrying about the negative. I'll deal with that at the end. Let's plot this graph first. Now, this time, the difference between kind of the +3 and the +2 is that the +2 is inside the brackets. So when it's outside the brackets, we're going to shift it up or down. But when the number is inside the brackets, we shift it left and right. And because we're adding 2, we're going to shift it to the left. So I'm going to sketch this graph. And all I'm going to do is I'm going to translate this line 2 spaces to the left. So again, I'll do it in using a dotted line. Okay, so it's going to look something like that. So now this is our turning point, and the coordinates of that point, well, if we're going 2 spaces to the left, it's going to be -4, 1. Because we're not going up or down, we're only going to the left. So this is the graph of this equation. Now we're almost done, but instead of f of x plus 2, we've got negative f of x plus 2. So negative f of x plus 2. So what we're doing is we're just taking this graph and we're taking the negative. So we are reflecting it over the x-axis. That's what we do. We reflect it over the x-axis. So it's going to look something like this. So now our turning point has gone from here to here. So if we're reflecting this coordinate over the x-axis, well, the x-coordinate doesn't change. It's still going to be -4, but the y-coordinate goes from 1 to -1. So our answer for this question is going to be -4, -1. And this is why it's worth 2 marks, because there are 2 stages. Question 19. C, D and E are points on a circle centered O. AEB is a tangent to the circle at E. So this line here is a tangent at this point. Now, before I go any further, I'm going to... there's something you should know about tangents. And tangents meet radii at 90 degrees. So this angle is 90 degrees. That's probably going to be really important for later, so I'll put that in now. Okay, let's carry on. So CD equals DE. So this length here is the same as this length, which means that this is an isosceles triangle. And angle AEC is equal to X. So AEC, so this angle is equal to X. Find the size of angle OED, work out what that is, OED, so we want to work out what this angle is in terms of X. Give reasons for each stage of your working. Okay, so the first thing I can see is what I mentioned earlier about, because this is a tangent and this is 90 degrees, I can work out what this angle is in terms of X. Okay, so this angle here, well, it's going to be 90 degrees minus X. So 90 minus X. And hopefully you can see that. If this is X, this is going to be 90 minus X, because the whole thing is 90 degrees. Okay, so this is 90 minus X. What else can I see? Well, I can use one of the circle theorems. So I can calculate or I can write down an expression for X for this angle because of something called the alternate segment theorem. So the alternate segment theorem states that the angle that a tangent makes with a chord, so this chord here, if we look at this chord, so the angle that this tangent makes with this chord, which is this angle, is equal to the angle opposite that chord. So the angle opposite this chord is this angle over here. So these two angles are the same. So that is also X. So let's write that down. So angle CDE is equal to X. And we need to give the reason. Remember, it says give reasons for each stage of your working. And the reason for that is due to the alternate segment theorem. Okay, we also do need a reason for this. I forgot to give the reason. So we need also angle AEO. Angle AEO is equal to 90 degrees, and that's because a tangent meets radius at 90 degrees. So let's sure we make sure we include that as well. And let's also say what angle CEO is. So angle CEO, well, it was the 90 degrees. Take away this x, take away x. So we can actually just say that that is 90 minus x degrees. Okay, so we've got this angle here. And now let's use the fact that this is an isosceles triangle. So because this is an isosceles triangle, these two angles here, so these purple angles, are going to be the same. So let's just call them y for now. Let's just call them y. Now before we go any further, let's make sure we write down the reason as to why these two angles are the same. So angle DCE is equal to angle DEC, and the reason for that is because this is an isosceles triangle and base angles in an isosceles triangle are equal. Okay, so we know that these two angles are the same. We also know that angles in a triangle add up to 180 degrees. So we can add these three angles together. So we're going to have x plus 2y is equal to 180 degrees. And again, we need to give the reason. So angles in a triangle sum to 180 degrees. Right, okay. So we can write an expression for y now in terms of x. So if we get y on its own for this particular equation, if we first thing to do, let's get rid of x from both sides. So we're left with 2y equals 180 minus x. And now if we divide everything by 2, we get y is equal to 90 minus half x. Okay, so we've got y, we've got the purple angle in terms of x, we've got the red angle in terms of x. Now to work out the angle we're after, we can just do the purple one, take away the red one. So, angle OED, what we're after, so angle OED is equal to the purple angle, which is y, is this angle, 90 minus a half x. And we're going to take away the red angle, which is 90 minus x. 90 minus x. I'll put it in brackets because we're taking away the whole thing. We're taking away 90 and we're taking away negative x. So if we simplify this, 90 take away 90, well, those two terms will just cancel out. And then we've got negative a half take away negative x. Sorry, negative a half x take away negative x. Well, that's just going to be a half x, because that's the same as negative a half x plus x. So our final answer is just a half x. And I think we've included all of our reasons. We've given the alternate segment theorem. We've given the tangent meeting the radius at 90 degrees. And we've given the two reasons about our triangles. So one of them, angles in a triangle add up to 180 degrees. And the other one, base angles in an isosceles triangle are equal. You might think that all of these reasons are obvious, but you still need to state them. If you don't state them, you will lose marks. Question number 20. Work out the value of x. Give your answer to 1 decimal place. Right. And this is worth 5 marks again, so there's a lot to do in this, and it looks like we're going to have to use a bit of trigonometry. So just looking at this triangle here, I've been given 2 of the angles and 1 of the side lengths. Now straight away I can work out what this angle is. So this angle is going to be 180 degrees minus 71 plus 53. As we know, angles in a triangle add up to 180. So 180 minus 71 minus 53, we get 56 degrees. 56 degrees. So this angle is 56 degrees. And now with this, we are now able to calculate this length here using the sine rule. Now the reason I'm using the sine rule is because I've identified pairs. So this angle here pairs up with this length. They are opposite one another. And this angle, the one we've just worked out, pairs up with this length. And the sine rule states that the ratio between one of the side lengths and the sine of the angle opposite, so the sine of 56 degrees, is equal to the ratio between this side length and the sine of the angle opposite it, which is 71. So the sine of 71. So now we can work out what this side length is. So if we multiply both sides by sine of 56, we get x equals 9 times the sine of 56 over the sine of 71. And we just need to pop that into our calculator. So 9 times the sine of 56, close brackets, times, divided by the sine of 71 degrees. And we get 7.89. I'm going to write down everything actually. 89126 554, and that is in centimeters, and that looks about right. If we do a dummy check, it looks quite close to 9, so that looks about right. And now we can use the cosine rule, because the cosine rules, in order to use the cosine rule, we've got all three, sorry, wrong pen. If we've got all three side lengths, we now have this one, we can use the cosine rule to work out what this angle is. And I should have mentioned actually, the sine rule and the cosine rule are in the formulae sheet at the front of your paper. So if you do forget them, they are there. So the cosine rule, let's write this down. The cosine rule. So that states that so a squared is equal to b squared plus c squared minus 2bc times the cos of a. And these a's, b's and c's just represent the side lengths and angles. So this capital A, that is this angle we're trying to work out. So if this is capital A, the side length opposite that is lowercase a. And then the b and c, it doesn't matter which way around we put the b and c. So we can just have the 10 centimeters as b and the 13 centimeters as c. So this formula here is if we had 2 of the side lengths and 1 of the angles, but we don't, we have 3 of the side lengths. So we're going to have to rearrange this formula so to make cosine of A the subject, because that's what we're trying to work out. We're trying to work out what this angle is. So if we make cosine of A the subject, and to do that, I think the first thing I'm going to do is I'm going to add 2bc cos of A to both sides, because I want to turn this into a positive. I'm going to put it on this side of our equation. So I'm going to add 2bc cos of A to the right hand side and add 2bc cos of A to the left hand side. So what's we left with? Well, on the left hand side we've got a squared plus 2bc times the cos of A, and on the right hand side, well, all of this will just cancel out, so all we're left with is b squared plus c squared. Okay, now let's get rid of this a squared from both sides. So if we take away a squared from both sides, now we're just left with 2bc times cos of A on the left, and on the right we've got b squared plus c squared minus a squared. So we're almost done, but we just want to get rid, we just want cos A on its own. So if we divide both sides by 2bc, so divide both sides by 2bc, that just gets rid of the 2bc on this side. So all we're left with is cos of A, and on the right hand side we've got b squared plus c squared minus a squared, all of that over 2bc. And now we have the cosine rule for angles. We can just substitute all of our values for our side lengths into this formula. So the cosine of A, well, it's going to be B squared, so that's 10 squared, plus C squared, so 13 squared, minus A squared. Well, we said that A was this number here, so 7.89. I'm just going to put dot 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 squared, and it is still saved in my calculator, so I can just put answer squared when I type this in, and then all of that divided by 2 times 10 times 13. So the cosine of A equals, and I've just saved a bit of time, I've done all of that already, and I get 0.795 dot dot dot. Now you can clearly see that this is not the angle, this is the cosine of A. So to work out what A is, we take the inverse cosine. So A is the inverse cosine of 0.795 dot dot dot. So I just need to put shift cos and then my answer, and that gives me 37.3345, and then that just keeps going on again as well. Right, now it says give your answer correct to one decimal place, so that is going to be 37.3 degrees. And let's just dummy check our answer. Although this isn't drawn to scale, it looks about right. Okay, if you'd got an answer of something like, 170 degrees, then you must have gone wrong somewhere, or -2 degrees. So I should be quite confident that I've got the right answer. Okay, we're on to the final question. 21. 50 people were asked which fruits they liked from apples, bananas and oranges. 11 people liked all three fruits. 33 people like apples, 6 like apples and bananas but not oranges. 15 like bananas and oranges. 5 of the people do not like any of the fruits. All 25 people who like oranges like at least one other fruit. 2 of the 50 people, so let's highlight this, 2 of the 50 people are chosen at random. Work out the probability that they both like bananas. Right, there's a lot of information here, and again, it's worth 5 marks, and there's a few ways you could do this. The way that's jumping out to me is to use a Venn diagram. So let's do that. Let's set up our Venn diagram, and we're going to have 3 circles. So, up our Venn diagram. So we've got, let's try and, okay, these are not excellent circles. Okay, very bad actually, but hopefully it's good enough for our purposes. Right, so 50 people asked which fruit they like. 11 people like all 3 fruits. So actually, let's just label this. So we've got apples, bananas and oranges. That's an O for oranges, not a 0. So we're going to put 11 in the middle straight away. 11 people like all 3 fruit. 33 people like apples. Now we can't do anything with that at the moment because we don't know how they're divided up. All we know is that this circle in total adds up to 33. Okay, so let's look at the next line. 6 like apples and bananas, but not oranges. So apples and bananas would be this bit, but not oranges. So there's going to be 6 in this section here. Okay. 15 like bananas and oranges. So bananas and oranges. So let's just do this in a different colour. This section here, I'm going to hopefully outline it to help it make it clearer. So in this region, there should be 15. There's 15 people like bananas and oranges. Well, we've already got 11 here. So to make up the numbers, this has to be 4 to make it up to 15. Okay, 5 of the people do not like any of the fruits, so we can put 5 outside our grid. And now it says all 25 people who like oranges. So there must be 25 people who like oranges in total. So all 25 people who like oranges like at least one other fruit. So there is nobody who likes only oranges. That's really important. So all 25 people who like oranges like at least one other fruit. So there's no one who just likes oranges. And we know that these have to add up to 25. So 11 plus 4 is 15. 25 take away 15 is 10. So that equals 10. Now we can come back to this statement here. 33 people like apples. So add these up and take them away from 33. So 10 plus 11 is 21. 21 plus 6 is 27. So 33 take away 27 is 6. I think that's right. So 12, 20, 12, 22. Sorry, 12, 23, 33. Yeah, that is right. Right, okay. What else can we do? So we filled in everything apart from this. This is the only one we've got left, but we are told that there are 50 people who were asked. So I'm just going to get the calculator out and add up everything. 6 plus 6 plus 10 plus 11 plus 4 plus 5. I don't need to write plus 0. That gives us 42. So this must be 8. So now we've filled in the Venn diagram, let's answer the question. So 2 of the 50 people are chosen at random. Work out the probability that they both like bananas. So there are, if we think about the first selection, there are 50 people to choose from. Out of those 50, how many like bananas? Well, we need to add up all of these numbers in here. So 6 plus 4 is 10. So that's 10 plus 11 is 21, plus 8 is 29. That's 29 out of 50. That's the probability of selecting someone who likes bananas. But now we have to select another person that likes bananas. So the denominator is now going to be 49 because we're now removing one person. And then the numerator is now going to be 28 because, again, we're selecting 2 people who like bananas. So the first person likes bananas. So now there's only 28 people left who like bananas. And we can just put this into a calculator. So 29 over 28 times 28 over 49. Oh, I typed that in wrong. Sorry, 29 over 50. Sorry, hopefully I'm not confusing you. Divided by 28 over 49. And that gives us 58 over 175. So that is our answer, 58 over 175. You could also write that as a decimal, but we'll just leave it as a fraction because it's a bit simpler. So we have come to the end of paper 2 on the higher tier. Hopefully you enjoyed that and it helped you, especially with some of the wordy questions where you might just need kind of a bit of guidance on how to get going. Like I said before, I'm going to do paper 3 next weekend. So hopefully you'll join me then. And that will be kind of just in time for your final maths. So thanks again for watching. And speak to you soon. Take care.